Hi, student. Now it's 10 a.m. 30th December. I would like to talk about the course for this coming semester, the second semester for senior student in electronics, microelectronics manufacturing. And many students wondering what course going to be about. Well, let's get started with the background, of this course. When I studied master degree in microelectronic manufacturing at RIT, or Rochester Institute of Technology. Yep, this is one I brought over from the States. And this course actually is going to be about Six Sigma program. That means you're going to use the program to evaluate your process capability, or to see that how well you can handle the process, because you want the final product to be yield 100% or 1, and you have to go through many processes. And this Six Sigma program you can apply to any processes or even service. And if you still remember, when you go to a restaurant, you sit down, they're going to have what? A small piece of paper, right? You have to evaluate that service to be best. You put 4, good, you put 3, fair, you can put like 2, or poor, P-O-O-R, 1. This is just for example, and you can take that one as the evaluation, and you can apply your Six Sigma program or Six Sigma process to evaluate that service. You can collect all information from customers who have lunch, dinner, whatever, so you can improve your service. So it can be anything. It's been around the world, or organizations, industry, services. They apply Six Sigma program. So that's for the short, to improve their service, to improve their process capability, to be the best. Okay. And then also I'm going to talk about cost evaluation, to see like when you let's say go to customers, right? You want to do some product, and you have to calculate for how much it's going to cost, how much the cost is going to be. So you can have profit, and also you need to set up your scheduling. Like what are you going to do today? What are you going to do to the next week? And also the cycle time, how long it's going to take. So they are all together, just like you going to work, in companies or industries. And you have to look forward. You have to look ahead to plan everything: cost, scheduling, the timing, and also how to manage your production line. So that's in the term of general. But for this course, first of all, the materials that I brought over from the States. This one is, I have a lot of materials. So today is reorganize my office, so I just take a look whatever going to be a benefit for students. It's going to be online class, I already put a YouTube channel for students. So some students who have nothing to do during the semester break, we have until like 11th January, right? That the school start. So feel free if you want to do some homework before. I already will send you your assignment. It's better than nothing, for you to just like sit down and you have one more semester to go to graduate. So it's coming soon. The time flies. Just like I woke up 4 a.m. today. Now it's already 10 a.m. And actually, when I study master degree in the program or this course, this is what I did. Okay, that's the lead frame for ship carrier, and you have die in the middle. Actually, I got this one from my student ASM. Starting from wafer, or it's created by pure silicon in this shape. You are going to do the process to create CMOS or even integrated circuit. You have like many electronics components, for example, transistors, resistor, capacitor, inductor, you name it, all electronic components, and a very, very small size. Micrometer, that's mean 1 in a millionth meter, very small. And for this course, I will assign you your homework throughout the semester. You can send me the same as just like student last year, attached file through my line, my Facebook, even my email. But of course, as students, to be convenient, the attached file is going to set up like group. I will tell you, what is the like group name. Well, about Six Sigma, as I mentioned earlier, you need to set up your target. For example, you want to make resistor 100 ohms, just for simplicity. And your target is 100 ohms, right? But of course, you cannot make like your resistance to be exactly 100 ohms. It's going to be a tolerant, plus and minus 10%. That's mean the lower scale limit going to be 100 ohms minus 10%. Sorry. So that will be 90 ohms, right? That's going to be your lower scale limit. And also for upper scale limit, that's going to be 100 ohms plus 10%. So that's going to be 110 ohms, right? So you have the tolerance between 90 ohms to 110 ohms, and your target is the 100 ohms. Of course, for example, you want to make 100 resistors, and you have to measure your final resistance of each resistor. That's going to be a different resistance, and you have to find the mean of your resistance of 100 resistors, and then you're going to calculate for standard deviation of sigma. And then if you want to see that what is your mean and what is your 6 sigma, 3 sigma on the left and 3 sigma on the right, or the greater than mean. And if your resistance of the limit between negative 3 sigma and 3 sigma from mean, or that's give 6 sigma. You are going to be like off target. So that's going to evaluate if you are past 6 sigma process or not. It tells you what is your defects. Maybe you're in the term of ppm or part per million. So that's the basic idea of your 6 sigma program. And for materials, I will have my own lectures. I have no textbook, but I will give you materials to read, and I will assign you some paper for you to translate, because you're a senior student and you're ready to go to work. You need to practice your English more and more. So this is my intention, for this course. And I will post the syllabus or the teaching plan what it's going to be. So it's coming soon on 11th, Monday of January. Be about 11 or 12 days. And the course, you don't have to worry too much about this course, because there's going to be no new equations. It's just about some concepts that you need to learn, and that's the real thing that you're going to work in, companies or industries. To give you an idea in the overall idea about what you're going to do when you go to work. So, but let's get back to what I studied, master degree in microelectronics manufacturing. We have to go through 75 to 80 processes to make CMOS, or to make integrated circuit. And does include RCA clean. You have to clean wafer. You have to do doping. And doping is mean like you want to change electrical property of your semiconductor, because the silicon is semiconductor, right? It can either conduct or not conduct. So it's just like you apply that one for a transistor, and transistor is what? It's work like electrical switch, right? Not like the switch that we press to turn on and off the light. That's we call mechanical switch. For electrical switch, that mean for transistor you apply your voltage to turn on and off your transistor. So that's why you have a digital 0 and 1. And 0 is mean it's not your transistor is off, and 1 your transistor is on. And that's how our semiconductor work, and apply implement for transistor. And more transistor, you have NPN transistor, PNP transistor, and you also have a complementary metal oxide semiconductor, right? That's the CMOS stand for complementary metal oxide semiconductor. So you have like metal, you have a semiconductor, sandwich together. That's make a CMOS, and you can apply CMOS to be like inverter. You learned that before in the junior invert class, like digital. And that's how we do the doping to change the electrical property of your semiconductor, and then you make transistor. So that's the bottom line of the transistor. And we have to go through processes, 75 to 80 processes, and then you need to do also implantations. You have to do silicon dioxide growth, You have to do masking. You have to do metal. You have to create metal contact because you need like to apply your voltage, right? You have the ground terminal. You have a voltage terminal that you want to apply to your transistor, and then we collect all information or data to see you pass the process or not. You get feedback, and then you improve your process, just like you're going to work in industries. For example, you need to set up when you want to grow silicon dioxide, let's say 100 angstrom, and then you need to go to the furnaces, and then you need to set up the voltage. You need to see the flow rate of oxygen. You can either to do the process with oxide, with silicon dioxide, or dry silicon dioxide. I'm not going to go to that because that's not the point. I just like explained what I did when I studied over there. Before you get some data, you need to go through many processes, and also it's going to be time consuming, but this is the undergrad course. So what I'm going to do is going to give you an idea about what related to the processes, or before you get the final product, what you have to do. That's pretty much. That's a very good course. That's you will learn and you will study. And for the final exam, also the university seem to be like also going to be online take-home final exam, because we believe that COVID-19 probably is going to last long. That means it's not going to stop soon. So you have to work hard, because nobody's going to ask you, professor cannot like go to ask you to do this, to do that, but they will see your feedback in the term of your homework, in terms of your projects. You have to take your responsibility for yourself. Well, that's pretty much I have to say. And let's see if I can brought everything together for class material, so it's easy for you to follow. And I also stick around here on the campus. You have any question, concern about the materials of the course, we do the same thing as you did, because last semester many students did quite well in electronic packaging, and I'm very happy about it. You take your responsibility. Of course, the more you work, the more you get. Think about soon you will graduate in about 4 months. Time flies. Okay, if I have anything to add on, I will let you know. Take care, everybody.